guess I was listening to the tunes yesterday and had the volume way up, jamming out in class yesterday. There we go. All right. Okay. So, boom. Conic sections. We just did 3 chapters ago, graphing parabolas, and they were up and down. Well, part of the conic sections is parabolas, but we're also going to look at them right and left. All right. And actually, you're going to find out conic sections are not functions. None of them are. We're going to graph parabolas in a coordinate plane. And by the way, I'm going to stop there. Just told someone that's interested in NASA. I call her NASA. Right. When we do parabolas, I'm going to show a video about the Hubble telescope because the mirror in the Hubble telescope is a paraboloid, which is a three-dimensional parabolic situation. And it's something historically you may not remember. How many people have heard of Hubble telescope? I'm going to be mad if no one raises their hand. I mean, Hubble telescope has revolutionized and changed our world as far as how we perceive what's going on in our universe. It's been revolutionary. Circles, and this is in no necessarily order of how we're going to cover them. Ellipses. Now, speaking of space, our orbit around the sun is elliptical. It's not circular. It's almost circular. It'd be really hard to see the difference, but it is actually elliptical, which is an oval. Then the last thing is hyperbola. And some people ask, why some of this math? Why do we need this? All of these have practical purposes for space. How things move in space. They're either circular or elliptical. I know. What am I trying to say? What are those things that shine in the sky when they come through every once in a while? Halley's Comet. There we go. Comets sometimes have hyperbolic motion out in space. But then also all these things are in, like, if you're an engineer or an architect, a lot of these are used in structures, these shapes, these ideas. So it's actually kind of important stuff. Do you have your hand up? Yes, what's up?
This is probably a dumb question, but is there like a equation I could graph of like a circle?
Yes, and that's going to be our first thing on Monday. Absolutely, in a coordinate plane. And that's funny that you asked that. He asked, is there an equation that graphs a circle? Yes, and it's actually 100% related to the distance formula. It really is, and that's how we're going to show you on Monday. I want to do circles first. That's what we do in CAT. We do circles and ellipses because ellipses are just a little bit different than a circle, and I like putting those together in days. But so we'll spend one day on circles, and on Tuesday and Wednesday we'll tackle ellipses. Is the plan. And I do want to over-explain this. I like that people know where things come from because then it's more than just memorization; it's knowledge. And then memorization just happens with more firm understanding. So the distance formula, this is what we're doing, and I'm going to grab 2 coordinates. I'm going to say 1, 2, and go ahead and feel free to put that coordinate there, 1, 2. And then 2, 3, 4, 5, 6, 5, let's say. 6, 5. And what I want right below me there, sneak that right under my picture. So what I want is the distance between those 2 points, how far they are. So I want the length of this red segment right there. Wish I would have made that straighter. Oh well. And then what I'm going to do next, it's really based off of the Pythagorean Theorem. This is the proof of the distance formula here. What I can do with dotted lines is finish this off and make a right triangle out of this with these 2 other dotted lines. And then what I can do is find the length of those 2 dotted lines. It's very simple, but I'm going to write it in a weird way so that you understand the distance formula. This is 1 for x, and then this is 6 for x. Everyone should know then already how long is this segment? 3, 2, 1, go. 5. Okay, only a few said it. I'm surprised. This is of length 5. Simply what you do is take these 2 and subtract them. This is a distance of 6, but then there's 1 short of that. So this distance is actually 6 minus 1, and that's how I'm going to write it. All right, I'm not going to write 5. And then this distance, same thing is occurring. This is 5 up, but you're missing this 2. So this is 5 minus 2 as a distance, which is 3. And then what you can do is understand the Pythagorean theorem exists. The Pythagorean theorem is c squared equals a squared plus b squared. So what c squared is equal to is, let's call this a and this b, 6 minus 1 squared. I know it's 5. I'm trying to compare this to the formula, though. All right? Plus 5 minus 2 squared. And that should be pretty reasonable. Oh, and by the way, what is c squared? I'm calling this c, I guess. That distance in between those 2 points is the hypotenuse. You know, some words you should remember from your days in whatever, grade school or last year. Then you square root both sides. All right, and that's what we end up getting for the distance formula. Okay, so the distance formula, when I don't know the coordinates, it is this. It is the square root, that square rooting I just did at the end, and it's the subtraction of the x's. Now, I don't care what you write. You can write x1 minus x2 or x2 minus x1. Doesn't matter. There he goes. He's tilting his head back, killing him back there. Squared, body language. Body language goes so far. And then the difference of the y squared. Okay, and then as I'm going through these formulas, it's good that we're doing this too. I'm glad this starts. And the reason we're going over these basic formulas and not talking about circles yet is because, well, the question, are we going to have an equation for a circle? Yeah, it's actually based off of the distance formula. But all these other formulas are going to be needed throughout the chapter. But it's good that we're going over this because I think in spring, you guys are going to have a SAT practice test while the juniors take a real one. And actually, these 3 formulas come up like almost all the time on an SAT exam. It always makes me sad, students that don't know these formulas. Then you miss these basic questions. The other thing is midpoint formula. Think of midpoint as average. What do you do when you have an average? If you bowl 2 games, you add those 2 games up and then divide by 2, and then that's your bowling average. So what is midpoint? It's the average of the x's, comma, the average of the y's. And often these 2 formulas, the last 2 that I just did, are reversed. I get people that subtract on the midpoint formula and add on the distance formula. And therefore you'll get a wrong answer. And it's on your shoulders when that happens. Now, I will say, you know, when we actually go into questions like this, the smartest thing to do is to graph these and actually make common sense out of stuff. Maybe not the distance formula, but definitely the midpoint formula. It always makes me sad when people put the midpoint formula wrong, get a coordinate for the midpoint between 2 points, and if they would just think about the graph, here's the 2 points, and your midpoint's over here in this quadrant. How the heck is that a midpoint when it's way over here and the other 2 points are right here? That's a lack of common sense, right? And that's what we need to do better on, some of us, with making sense out of your answer. All right, so that's how you know, you can kind of be okay there. All right, and then I put some things on our notes last hour that I'm going to do the same with you. For physics, a lot of times they use change in, and they use the word or the symbol delta. And actually, this is slope, delta y over delta x, which is change in y over change in x. So that's a very, you know, big symbol there. Or rise over run. Anything you need to do to get to understand that the y's are on top and the x's are on the bottom. And really what it is it's the difference in the y's again. So now we got subtraction. And you can see the coordinates are x1, y1. Sorry, I cut it off a little bit, moved that back. So there's point A, there's point B. This is one coordinate, this is the second coordinate. That's all those subscripts mean. I could do y1 minus y2, but whatever you do in the numerator, Computer is working worse and worse and worse than ever. Do the same in the denominator. Go in the same order. So if I decide to do y2 minus y1, I must do right to left, x2 minus x1. If I switch it, y1 minus y2, fine. But now you have to do x1 minus x2. Anyone that switches them and goes out of order, that's on your shoulders. And that's why you get wrong answers. Okay, so make sure we're okay on that. So you got two formulas with minus and one with a plus, and you got to figure out which one's which. Okay, one more thing that we have to write, though, that I did not type in here. I think back in the day in this Algebra 2 book, we had just, I know in the Algebra 2 book, there was an equations of line chapter for sure. Equations of lines. I'm going to give you two of them. Slope-intercept, it should actually be called slope y-intercept, but they always just call it, I'm missing words there, or letters, slope y-intercept, but it's slope-intercept. Y equals mx plus b. That's 3 times. I had to write an m there. Love you, computer. And then my favorite, I'm going to do both here. Point slope. I like that one a little bit better. I'm going to have 2 questions that I have to find an equation of a line. I'm going to use both of these. That is y minus y1 equals m times x minus x1. Then there's another equation of a line called standard form, which you should have done last year. That one we don't really need right now. I don't see much use for the standard form equation. It's important. I don't want to knock it down, but not for today. It's either one of those two, and usually you end up with a y equals mx plus b. Even if you use this, I'm gonna use this, but then when I'm done, I'm gonna turn it into that just by simple solving skills. Okay, so the kind of questions that are good practice for these, good SAT questions. Sometimes they ask this, and start thinking about geometry, but in a coordinate plane. When we start January, the next semester, we start with geometry concepts. We can kind of think of conic sections as geometric in a way, though, because they are shapes, just like, circles. That's usually in a geometry unit. So kind of leaking into that right now. All right. So some terms to remember. Classify each triangle as scalene. That is no equal sides. Try to remember that. Isosceles, that is 2 equal sides. Equilateral, that is all 3 are equal with the given coordinates. Oh, I forgot to do that. Then find the perimeter of the triangle. Darn it, I didn't do that last hour. So basically, you just add the 3 sides when you're done. And I guess I could grab out a calculator. We could do exact and approximates with the answers that we end up getting here. So if you have the time, this one maybe not so much, but I think I'm still going to do it. I'd graph this. It's not that you can really see distance, but on our next question, you better darn well graph it to make sense out of it, that common sense aspect. All right, so -2, -2. So the ability to move around in a coordinate plane. And we've had some coordinate plane questions already when we were graphing quadratics. And then -3, 3. So here's -3, and then here's 3. Be nice to have a grid on this, but it's okay. We can survive. And then 2, 1. And then this is our triangle. Ooh, almost looks to me that it looks equilateral. That ain't good enough. They could be off by a millimeter, like each side, so you don't really know that. And then actually what I should do is label these so that I get some structure of where I'm at here. Or like, who am I finding? Which side is which? Make this B and this C. Okay, so if I need to know if they're scalene, isosceles, or equilateral, I need to know the distances. So these are 3 different distance formula questions. First one I'm going to do is AB. AB equals the square root of. So AB, it doesn't matter which way you go. I just have the thing where I go backwards. I do x2 minus x1. just because other formulas do that. Sometimes it does matter, but not too much. So the x is subtracted. -3 minus -2 plus 3 minus -2. 3 minus -2. Oh, that's bad. Okay, did I do that right? -3 minus -2. Okay, yes. I just wanted to double check something. I was almost thinking I wasn't getting the same answer as last hour. But minus a negative is plus, and then this is -1 squared. And then this is plus, so this is 5 squared. So ultimately you have the square root of 1 plus 25, which is the square root of 26. Okay, so now I'm holding and waiting to find the other two distances and then compare them. So it's really pretty simple. So let's move this along. Let's go to BC and insert those parts. B to C, so I'll do 2 minus -3. Maybe, if pen lets me. 2 minus -3, and then it really doesn't matter. 1 minus 3. On this formula, it's okay, because 1 minus 3 is -2, but then I square it, and I get 4. If I did 3 minus 1, I get 2, and then I square it, and I get 4. So it's really hard to screw up the distance formula. Even if you accidentally switch them and go in a different order, it still doesn't matter. All right? 2 minus -3 is 5 again. I'm not going to write that below. 5 squared is 25. Oop, that's exciting. But then this one, 1 minus 3 is -2. -2 squared is 4. So right now, we're not equilateral. Okay, because they're close, though. Boy, if you get those decimals, which I'll type it on my calculator, maybe not separately, but they're really close. All right, but not quite. So it is that millimeter off that I was saying, like barely not the same distance. Then the last one, A to C, we do 2 minus -2, which is 4 squared. And then 1 minus -2, which is 3 squared. 16 plus 9, square root of 25. 5. Look at how close these are. Square root of 26 is going to be like 5.0, I bet. If you type that on your calculator. I doubt it'd even be 5.1. So close, but no equal sides. So it's scalene. And now for the perimeter, I'm not going to bore you with that. You just add these three. Go to your calculator and type them if you wanted the decimal, the approximates. You should be able to handle that. I don't want to talk about this one anymore. Okay? Good to go? Everyone fine? Nothing really exciting on a Friday, but nothing really difficult either. A lot of review. Okay, and then I love these kind of questions, right? So write an equation of a perpendicular bisector of the line segment joining these 2 points. Again, you'd be a silly fool if you did not graph this just to get some sort of concrete idea of what's happening here. So as you write the question down, I'm going to slowly graph this. And then 1, 2, 3, 4. 5, 4. -1, 6. So we have somewhere along these lines this segment. Ooh, happy with my straight line there. Sometimes I can't get that. A little crook at the beginning, but then became good at the end. So I need perpendicular and then bisector. I'm going to hit the word perpendicular first, and I'll highlight that in yellow. Perpendicular is this symbol. So perpendicular lines, we need something defined and reminded of you on this. Perpendicular lines, they have a relationship. Does anyone remember what the relationship is with their slopes? Let's see if anyone can remember. No? Yes? No? Anyone want to raise their hand and try to remember? Are you trying to Yeah, go ahead. Opposite is one of the things. Slopes are opposite. You're missing something. Opposite what? Do we know the big fancy word I'm going to say? Yes. Absolutely. Nicely done. Reciprocal, being real obnoxious in how I write that so I know how to spell it. And I think you were pretty much said that. Reciprocal. All right, opposite reciprocals. And then even in the other hour, I did a little example of this. What's opposite reciprocals? And I just picked a fraction. I think last hour I put like negative. No, I don't think it was this, but I'm going to do it this time. -7/2. A little different fraction than last hour. So what is the opposite reciprocal of that? Well, first of all, it's opposite. So it's plus. Reciprocal is flip. So there's an example of two slopes that would represent perpendicular lines. And we're going to go ahead and draw our line at the end when we find it, and at least have an idea that, yes, it does look like those make right angles when I'm done. All right, so that's the only thing that we could kind of prove, in air quotes, prove that this actually is true. Lines that have slopes that are opposite reciprocals of each other. And then bisector, that means my new line will have to pass through the midpoint. That's what bisect means. It cuts in half. Midpoint is in the halfway position of that segment. So therefore, the perpendicular bisector must pass through the midpoint. All right, so those are the kind of things you got to know there. Okay, so perpendicular bisector means pass through the midpoint. So I got to do two things. I got to find the midpoint of this segment, and I also got to find the slope that this segment makes so that I can find the slope of my new line. All right, and I'll do the old line in red. It doesn't matter which one you find first. I'll start with slope. Remember, slope now is the difference in y's over the difference in x's. And I chose 6 minus 4. Now I'm locked in. I must do -1 minus 5. You flip-flop that order, it's on you. Those that make these mistakes. -5. Okay, yeah, I guess it is the same as last hour. Good. Panic for a second. That means my new line, which I'm going to find in green, the slope is positive 3/1. That's the slope I'm going to use for my new line. And then for my new line and this red segment, they both share this point that I'm going to find next. So I'm going to find it in green. I'm going to find the midpoint of this new or this segment, and then that's where the new line is going to cross this thing. So midpoint, that's weird that I have here M for slope. I don't know why they use M for slope, but they often do. Like it was MX plus B. So the midpoint is the average of the x's. Let me get those two coordinates. So 5 plus -1. And then I made a mistake last hour, and I'll be happy to admit it. But I caught my mistake right away. Caleb, you're not sleeping, are you? It looks like you nodded off. You almost broke your neck with that little head bob. All right? But anyway, I put Y. You okay? I put Y's first, then X's. And then this is what I was talking about before. How can we have two points that make a segment, and then here they are, and then you find the midpoint, and the midpoint's over here. All right? Common sense. And I caught my mistake. I did Y's comma X's, and then my coordinate was not even near where this segment was. That's where I just have problems with some of the things that we do in here. We're not thinking. So I did make a mistake, but I caught it immediately because I graph and I check myself. All right, and make sure I don't make those silly mistakes. Anyway, -5 plus 1 is -4. I'm sorry, 4. 4 divided by 2 is 2. Kind of sneak this over here because I need room for my equation of a line here. And then 10 divided by 2 is 5. And then if I graph this, 1, 2, 1, 2, 3, 4, 5, it does appear to be in the middle of that thing that I graphed. So this does make sense. This is sensical. And it is in the right position. It looks like it's in the middle. I kind of missed my 2 comma, so make this a little larger than really looks like it's in the middle. Okay, and now we got to find an equation of this line, and it's the green parts. In this first one, I'm going to do point slope. Y minus, and then I pick. I'm sorry, it's the midpoint. I was going to say pick one of those. No, it passes through the midpoint, which is the y-coordinate 5. And then the slope is 3x minus 2. So highlighting this, you take this x-coordinate, place it there in point slope. This y-coordinate, place it here. And then the slope that I found for a perpendicular line goes there. That's point slope form. That's all the parts that go in. This is my favorite because then all I have to do is distribute and then add 5. And usually I do that in one step. So I get 3x minus 6. And then I add 5. Y equals 3x, add 5 minus 1. And then I'm going to go ahead and graph this just to make sense out of this and show you how this does actually look like it makes a right angle. Slope, intercept. Intercept is -1. Rise 3, run 1. And then rise 3, run 1. We hit that midpoint. And then when I graph that, that looks like it makes a right angle with that red line. So therefore, it does seem to make sense that that's the line that is the perpendicular bisector of the segment. Okay? So good little practice there. Understanding how to graph a line as well. Nice. Okay, got to move on. Everyone okay? All right. Got some head bobbers out there. A little tired on a Monday. What? Friday. Oh, Mr. Samuelis. Okay, example 3. Median. Fumble. Median of a triangle is a line segment joining a vertex and the midpoint of the opposite side. Okay, so a little geometry definition review. The ordered pairs represent vertices of a triangle. Write an equation of a line containing the median that joins the first vertex to the side opposite. So I'm going to draw what we're trying to do here. Wish the coordinates weren't so large, but we'll deal with it. I'll do little tick marks. 3, 10. 1, 2, 3. Probably too big there. 1, 2, 3, 4, 5, 6, 8, 9, 10. I wish I had a grid, but I don't. Looks like I did a little different scale on the Y's, made them a little tighter than the X's. Oh, and I'm gonna pay for that. 3, 4, 5, 6, 7, 8, 9, 10. 10, 8. So it's right around over here. A little bit lower by 2 than that other coordinate. And then 4, 2. This one's not as bad. 4, 2 is like right here. All right, so we got this triangle. And then the directions specifically say the median from the first coordinate or the first vertex. So it's from that one. So what I want is this midpoint, and then I want the equation of that line that connects from this. This is called the median. So I want the equation of the line that goes through that median, through this red line. I'm finding the equation of this red line. I'll make it a line. I'll put arrows that it goes through there like that. Okay, so drawing it out makes sense of the situation and makes sense of what I have to do. So yet again, I need the midpoint, which is actually the midpoint of, my bad, I get myself confused if I don't label these again. This is A. B is 4, 2. Why did I do 10, 8 first? It's weird. Or second. And then that's C, 10, 8. So I actually need the midpoint of BC. Bless you. Midpoint is average. So it's 10 plus 4 divided by 2. 8 plus 2 divided by 2. All right, that becomes 7. I'll put this over here for space below. 7, and then this is 5. And if I graph 7, 5, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, it does appear to be right there. So this is a sensical answer. When I make the picture and I know what midpoint means, it does graph to look like it's in the middle. It's not in a different quadrant, kind of thing. And then I need the slope of that red line now. And now I have two coordinates that I can find that slope. Okay, I have that and that. So we're good to go on that one. So I have to find a slope between this point and that one, which is y's 5 minus 10. If I go that route, if I go 5 minus 10, then I must go 7 minus 3, that route. And then this becomes negative 5 over 4. And that's the slope. There's nothing else I can really do with that. This one, I'm going to go ahead and do y equals mx plus b. And then you have two choices. You can do whatever. I'm not going to force you to do one y equals mx plus b or y minus y1, blah, blah, blah. You do whatever you're comfortable with. I, as a teacher, are showing both methods here. And then you choose. And if you remember this one from last year, go for it. 7 is x. 5 is y. M is m, or slope is m. So when I insert those things, then I just have to find b. Don't touch your calculator. Be Lexi Samulus and understand your fractions. 5 equals negative 5 fourths times x, which is 7, plus b. It's the fact that you're using your calculator so much for these questions why you don't know your fraction rules. I'm actually talking about my seniors. Very, very bad with fraction. I throw a fraction on there and they think it's like calculus. I'm doing something major here. All right? Not all of them. I'm talking about a handful that struggle. Many are knocking it out of the park. 7 over 1, to multiply this, you multiply across. Multiply the numerators, multiply the denominators. So I'm going to continue my work over here. This is 5 equals negative 35 fourths plus b. And then I'm going to add 35 fourths to both sides. Lexi Samulus knows, that's my 6th grader, to add these two, I need a common denominator. And this is where we can't be blown away by this. All right, common denominator 4, 20 divided by 4 is 5. So that's writing 5 with a common denominator compared to the other fraction. And then you add the numerators, put it over a common denominator of 4. 6th grade. Maybe some of you have 5th grade. Depends on which school you go where you do that stuff. She probably did it in 5th grade too, then just a reminder in 6th, and then get a little bit more complicated. That's usually how math goes. Don't be all proud of yourself. My CAT students get all proud of themselves. Circle that answer and move on. Did you find the equations of this line? Yes or no? No, you just found the parts. Now you got to put the parts in. You bring y back. You insert the slope where it belongs, because that's the slope of this line forever. And now you insert the y-intercept, because that is the y-intercept of this line. That is the y-intercept forever. You bring the y and the x back. That's the infinite amount of other coordinates that make the line. Input, say it. That's what a graph is. It's a series of inputs and outputs that make the equation true. That's why I need the x and y positions. If you don't understand that to this point, I don't know where you've been since August. That's why I've been saying input, output all year long for every single graphing that we do. I guess I'm talking more about my CAT class. We do a lot more graphing in that than you guys. You only had one chapter with parabolas. So, all right, a couple more. Oh, wait, that's actually going to be it. Nice. One more. And I do like this one. I like this one a lot. I was talking with Mr. Stronowski that we missed this book. We wish we never had to move on and do math 1, 2, 3. But don't get me started on the whole change of curriculums. You don't know anything any better, but the books that we had in the past were really, really, really good. So use the given distance d between the 2 points to find the value of x. Really good constructed question here. So give you a minute to write this down. What time we at here? We do a little better than last hour, but still. This one's going to take some time too. Mentioned a couple weeks ago that I heard on the news that maybe the mask mandate's going to, be released a little bit or loosened up, and then I just saw a news story the opposite this morning. Sticking with the mask, Governor Pritzker. So, just a sick awareness thing is why I just thought about that. D equals, again, it might be a nice review here. And I don't care if you put 2 or 1. I'll switch it. All right, it's the difference of x's. Try to remember that. Maybe just it's only midpoints plus. All the others are minus. I don't know how else you can like trick yourself to not screw that up. That's why I went through how it's related to the Pythagorean Theorem. You know, if you graph these points, but you're missing the coordinates, so it doesn't really help. Yeah, you're just basically going to have to memorize. All right, I'm not highlighting. You insert the parts that you have, and then I guess I'll call this x1. Last hour, I did -4 minus x, and it didn't matter. This hour, I'll do x minus 4, okay, and it doesn't matter. Because when I do x minus -4, you would get the same result if it was -4 minus x with what I have to do next. It's actually pretty interesting. But we're not going to show that. We're just going to do this. All right, and then the y's are, I went x minus 4, so I should technically go 7 minus 1, although it doesn't matter. 7 minus 1 is 6. 1 minus 7 is -6. Both of them squared are still 36. So it's not a big deal. Okay, and then I'm not showing this. I'm just doing it. What F word do I have to do with this? Starts with an F. 3, 2, 1, go. Don't say factor. FOIL. If you square x and square this 4, it is 4 actually, you should be jettisoned out of this class at this point. If you're not foiling, I'm done with you. All right, x times x is x squared. Write it twice if you need to. I can foil fast, and the majority of you probably can as well. Because imagine another x plus 4 here. You'd have x times 4 and another 4 times x. That's 4x and 4x, which is 8x. I really hope some people can foil this fast and not have to write them twice. And then you take 4 times 4, the last of FOIL, and get 16. And then I told you this is 6 squared, which is 36. Now, how do I free this out of the square root? What do I do to both sides? 3, 2, 1, go. Square. We just had that chapter. How do I free a square root? Now, pay attention over here. Common mistake. How do I square this? You just said I had to FOIL this when it was plus in between. When it's times in between, yes, you do square both parts. That is legal. The reason is something squared means something times itself twice. If you look at it that way, then sure, it is 6 times 6, which is 36, and it is root 2 times root 2, which is 2. So yes, you do square the 6 and square the root 2, and then go ahead and find that product next. So hopefully you understand it whatever way you need to do to get this taken care of and not make those simple mathematical mistakes. And then I'm going to be a bit lazy here. Not lazy. I don't want to write all these extra steps. This is 72 here. So I'm going to subtract 72 from both sides. And we should be able to handle that. Why am I doing that? Because of chapter 4 in the Math 2 book. I have an x squared and an x I must solve by maybe factoring. Let's see out there. Does anyone know if this is factorable? If so, tell me the numbers. Boom. 10, -2. So that means x plus 10, x minus 2. Good FOILers, good factors. Just double check yourself before you wreck yourself. X squared, -2x and 10x is 8x, -20. Good. Don't draw the lines because some people actually FOIL, and then they end up back at this step, x squared plus 8x minus 20. No, you just wanted to check. Is this right? Wait a minute. How did I get 2 answers? This is strange. What's going on here? It's actually very simple. I have -4, 1. Going to do it again. And then apparently blank comma 7 could be either -10 comma 7 or 2 comma 7. If I graph it, it will make sense. 2 comma 7 is way over here. 2, 3, 4, 5, 6, 7. -10 comma 7, -5, 6, 7, 8, 9, 10. Comma 7 is over here. And now my scale is probably a little bit off. But doesn't it look like these two distances are equal? Doesn't it? That's why there's two possibilities. And both possibilities are completely valid. So if I'm over here, the distance from here to here is probably going to be 6 root 2. Not probably, it is. And then the point over here has a distance of 6 root 2. Same distance on both sides of that negative 4 comma 1. So both answers are valid for this question. And I'm done. Okay, so good little questions reminding you of some geometry concepts, but then usage of these formulas. Really, really, really good. So love that book, missed that book. Okay, I'll stop sharing.